All right, now we're going to do the next 10 questions. So, number 10, most sediment is compacted in litter forms. Shale bedrock is. The answer is clay. If we go to our ESRT, we could see that we look to see clay is here, and it is made up of small particles, and those small particles make up shale. And that's pretty much what you got to do for that one. Number 11. In which two equations is oxygen the second most abundant element by volume? So when you look here, the important thing to remember is second. I know when we were going over it, I think we mentioned it was the first in some classes. However, we're looking at the second. So in order to do that, we go here, and then we have to go to the first page. And over here, we see the crust. Oh, there we go. The crust here. So we know that oxygen is actually the majority of the crust. However, in the hydrosphere, which is your ocean, and your troposphere, which is your lower portion of the atmosphere, in these two, it is the second most abundant, because we know water is in the oceans and the lakes and streams, and that's 2 parts hydrogen to 1 part oxygen. And then nitrogen is mainly found in the atmosphere, followed by mostly oxygen second. And then all the other gases only make up about 1% of the atmosphere. Which two properties are most useful in distinguishing between galena and halite? All right, this one is another one for the ESRT. So we're going to look at galena and we're going to look at halite. If we go to the end of the ESRT, we're going to find that galena is up on the top here. So galena is here. And we know that galena has a metallic luster. And then halite is over here. And we know that halite is non-metallic luster. Remember, all things have a luster to it. Sometimes it looks like a metal, and then other times it doesn't. So that's the distinguishing characteristic. And then if we look over at galena and we look at the color, it's silver or metallic. But then if we look at halite, it is colorless to white. A lot of the times it looks very clear. So another answer in the ESRT. All right, number 13, the graph shows the decay of radioactive material over time. How long does it take for this radioactive material to decay for 2 half-lives? So we know that after 1 half-life, we go up here, and in 1 half-life, 50% of the radioactive material became the daughter. So if we have 50% of the material, we know that 25% is going to be left over on the second half-life, which is 10 times 10 to the third. So your answer is number 3. Remember, if you're starting out with 100% of something, after 1 half-life, it's going to be 50%. 50, sorry about that, ladies and gentlemen, 50%. And then if we do, boy oh boy, all right, so let's go over to this wonderful advanced. We're going to go here, tools, comment and markup, pencil style. And then you're going to have 50% over here. So this is 1 half life. So let's look at the second half-life. In the second half-life, this is the parent here. If it's 50, it's now going to be 25%. And on this side, you're going to have 75% of the daughter. All right, so 25%, 25%, and that gives us 10. Next question. A $65.5 million impact crater in Mexico provides evidence of the cause of extinction of the ammonoids. All right, so this is another one that it's in the ESRT. If you go down to, you go here, and you go to the ESRT, you are going to see geologic history, 65 million years. So you're going to go over here to 65 million years, and it says, look, ammonoids were extinct. Piece of cake. All right. Control Z. I'm supposed to hit Control Z. Wonderful. Okay, next question. When did the earliest humans appear on Earth? Again, you go to the geologic history. Remember now, these are all questions on the January 2013 Regents exam. So we know that it's pretty heavy in using the ESRT. So the answer is the Pleistocene epoch. If we go to the ESRT, we could see over here that humans are here. And this is the Pleistocene. Piece of cake. Next question. A landslide is an example of mass movement, ladies and gentlemen. River deposition, we know that's sediment that's in a river. Glacial scouring, that's scratching and abrasion. Chemical weathering is usually by acid rain or water and oxygen causing rust. However, when you're talking about mass movement, you can have some area here. Remember the house, all those houses that we saw in one of the examples. As water continues to fall down, it is going to infiltrate. As it infiltrates, oh boy, this is not my cup of tea, ladies and gentlemen. As it infiltrates, what's going to happen is it's going to get wet, and then you're going to get you are going to get an area that is going to fall down, and it's going to be a landslide. Mass means that you have a mass of land that is moving. Next question. Which of these particles has the same density and volume? Each of these rock particles below has the same density and volume. Which particle will most likely settle the fastest rate in moving water? Remember, if it's round and smooth, it is going to fall through the water the quickest. I like to talk about a piece of paper. If you're going to drop a piece of paper from the top, let's just say from the ceiling, it's going to be moving back and forth, and it's going to take a while in order for it to hit. However, if you have that same particle and you make it round and you drop it from the top of the ceiling, it's going to hit the ground much quicker. So the next question. Which rock weathers most rapidly when exposed to acid rain? Your answer is going to be limestone. I missed that one as a question. Shame on me. Answer is going to be limestone. Because if we go to the ESRT, if you forgot, the ESRT says limestone Limestone is made of calcite. And if you were going to look at calcite, calcite bubbles with acid. That's it. What is the approximate minimum stream velocity needed to keep a particle in motion as a diameter of 10 centimeters? All right, we know we go to the stream velocity chart. On the stream velocity chart, we go to 10 centimeters. Now this is stream velocity on the bottom. 10 centimeters is here. We go across. There you go. We go across. And then you try to go up. So it's a little less than 200. We go over to the question, we would pick 190. Which change is most likely to occur in a landscape if the climate is humid to arid? Wind would become more important agent of erosion. If you have less water, you're not going to have a lot of chemical weathering, you're not going to have a lot of vegetation, you're not going to have surface features will become more rounded, you're going to have more wind. That is going to cause erosion. The surface bedrock of the Hudson Highlands consists mostly of. All right, another ESRT question. If we go here, we're going to check this one out. So I like to go to this one first. The Hudson Highlands is here. And then I see the Newark lowlands is this little bit here. So I'm going to look for this little bit in the spot directly above it to find out what type of rock it is. So right here, this is the area that we were talking about, that little Newark lowlands. So we're trying to look at this area, find out what it is. It's got a bunch of squiggly lines. If I go over here, I've got some squiggly lines. It is made up of gneisses, quartzites, and marbles. I go over to this, and I can see that it says gneisses, quartzites, and marble. All right, that was the next 10.